So here we have our sample question that has to do with 5.2. Not that many questions come from 5.2 because remember the next unit we're going to be adding to those combination of rules. So we're going to have more questions based on 5.3 where you're going to be learning how to add another rule to the product, quotient, and power. But right now, we know this is a combination of rules. You have an outside exponent and inside exponent, so you know you have power, and we have the same basis. So when you have the same basis, you know we're going to have product and quotient rule. So the first thing that we're going to do is step 1 out of the 4. Make sure every variable, coefficient, constant all have an exponent written. Yes, yes, uh-oh. So if you have one corner that doesn't have an exponent, we told you, just slip in a 1. Uh-oh, no exponent. So there's an understood 1, so write it in. Uh-oh, this variable still needs an exponent. And even this, your coefficient, it needs an exponent. Okay. Second step, we can distribute this outside exponent to all inside exponents. Only to exponents, never to the base itself. So again, do not do 3 times 4. It's not going to have a 12 in here. Also, if there's a negative number here or here, make sure you distribute this to the negative sign. Because this is an even number, the negative would have disappeared when you distribute. This one doesn't have a negative sign, so we're good to just distribute to exponents only. So this is our step number 2. Remember, you distribute to the top exponents and also to the bottom exponents if the fraction bar is inside of the parentheses. When you do this, multiply. Keep the same basis. So we're going to have A, but 4 times 4 is 16. We're going to have the base B, but 5 times 4, 20. We're going to have the base C, 1 times 4, 4. We're going to have the base 3, but 1 times 4, 4. We're going to have the base A, 1 times 4, 4. And we're going to have the base B, 1 times 4, 4. Now that we have this, then we said our third step. Do you have any like bases? A, B, C, 3, A, B. Oh, we got some matches. So that means we have some like bases. So for the like bases, we said ask yourself the 2 questions. For the like base, let's start with the matching A's. You ask yourself, where do you have more? Top or bottom? 16 versus 4 of them. You have 16 A's on top, clearly more A's on top, so I put the base of A on top. By how many more? If you have 16 here, but only 4 down here, that means there's an extra 12, remember we're subtracting, on top. For B's, where do you have more? Top or bottom? 20 versus 4? Yeah, clearly we have more B's on top. So 20 and a 4 at the bottom. 4 will eat into some of these 20, but they'll be left 16. Remember, subtract 20 minus 4, 16. Now notice there's no base of C. So if there's no base of C except on top, then clearly you have more on top. And there's nothing on the bottom to cancel out with, so you just bring it down. Okay? So if they don't have a matching base, then just keep it where you found it. Same guy here. There's no other 3's here, so keep it where I found it. Notice I found it at the bottom, it stays at the bottom. So now we don't have any like bases. A, B, C, 3. They're all different from each other. So we are done step 3. We asked those 2 questions. Finally, step 4, simplify any numbers like coefficients or constants, if possible. This, they're all variables, so I can't really simplify any of these. So I'm going to keep it as A to the 12th, B to the 16th, C to the 4th. But notice, this down here, I can simplify that. 3 to the 4th. Be careful, you should know, this means write out the base. 1, 2, 3, 4 times. Multiply it out. 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay, I don't want you to say 3 times 4 is 12. I told you there should be no 12 here. 3 times 3 times 3 times 3, 9 times 9, however way you want to see it, is 81. So our final answer is this. Much simplified